when we differentiate the equation of a curve, we say y equals some function of x, like this question here, y equals 3x squared minus 2x plus 3. But when we differentiate to find dy by dx, what we're actually doing is we're finding the gradient of the curve. So if we have this example here, find the value of the gradient of the curve at the point 3, 4. The first thing I need to do is say, okay, well, gradient is the same as dy by dx. We think gradient, we think dy by dx. So let's differentiate y. So 3x squared differentiates to give 6x, minus 2x differentiates to give minus 2, and 3 differentiates to give 0. So we have differentiated. What we're asked now is at a specific point. Now this gradient is the gradient at any point on the curve. All that we need to do is put an x value in and we'll be able to find the gradient at that point. And I know at the point 3, 4, x is equal to 3. So at x equals 3, dy by dx is equal to, well, 6 3s are 18 minus 2, which is 16. And so we were able to use differentiation to find the gradient at a particular point. The gradient of the curve is exactly the same as the gradient of the tangent to the curve. So if we're asked to find the equation of a tangent, what we need to do is work out, first of all, dy by dx to find the gradient. And then we need a set of coordinates. And here we have one coordinate, x equals 1. So the first thing we have to do here is find the y coordinate. And so for the y coordinate, we're going to put it into the y equation here. So y equals 4x squared minus 2x. And if x is 1, y equals 4 minus 2, which is 2. And so we have a point 1, 2. That's the point we're going to use. Next, we know y equals 4x squared minus 2x. Now we want to find what the gradient is. So dy by dx is equal to 8x minus 2. Now, we want to know what's the gradient when x is 1. So at x equals 1, dy by dx, the gradient is 8 minus 2, which is 6. So we're going to use y equals mx plus c. I know that we're going to use the point 1, 2, and we're going to use the gradient as 6. Remember, in y equals mx plus c, the gradient stands for m, or m stands for the gradient. So let's fill these in. Y is 2, when the gradient is 6, the x value is 1. And we rearrange that, c is 2 minus 6, so c is negative 4. And so finally, the equation of the line, y equals mx plus c, so y equals, we know the gradient is 6, so y equals 6x, and we now know c is minus 4. So there's the equation of our line. So in this example, we're asked to a couple of wee questions first, and then we're asked the equation of the tangent to a curve, and then asked to do something to it. Now, first of all, it says, find where the curve intersects the y-axis. Now, at the y-axis, we know that the x values are 0. And that's sometimes a wee bit counterintuitive. Sometimes we think, oh, it should be y equals 0. No, but at the y-axis, x is 0. So what's the y coordinate? Well, when I put that into the y equation, it's y equals 0 squared minus 3 times 0 plus 2. In other words, y equals 2. And so at the y-axis, it crosses at 0, 2. When we're talking about the x-axis, though, the coordinate, to find the coordinates, we need to know that y equals 0. At the x-axis, all the y coordinates are 0. And in this case, just need to be a little bit careful. When we put it into the y equation, we get 0 is equal to x squared minus 3x plus 2. What we're left with here is a quadratic equation. And I know I can factorize that as x minus 2, x minus 1. And so either the first bracket equals 0, this one here, x minus 2 is 0, and that's x equals 2, or the second bracket equals 0, so x equals 1. And again, we started by saying that the y value is 0, so this is the coordinate 2, 0, and this would represent the coordinate 1, 0. Now for this second question here, find the equation of the tangent to the curve at the point where the curve intersects the y-axis. Now we've already seen it intersects at the y-axis at 0, 2. So that's the coordinate that we're going to use here. We're going to use x and y values as 0 and 2. But we want to find the gradient, because to find the equation of the tangent, that's a straight line, so we need a gradient. So let's find the gradient. If y equals x squared minus 3x plus 2, we differentiate y with respect to x, so dy by dx is 2x minus 3. Now, when x equals 0, because we're looking at this point when x is 0 and y is 2. So if x equals 0, dy by dx, the gradient, is 2 times 0 minus 3, so it's just minus 3. And so we're going to use x value and y values of 0 and 2, and we're going to use a value for the gradient as minus 3. And let's put that in to the equation of the line, y equals mx plus c. So y is 2, the gradient is minus 3, and x is 0, so 3 zeros are 0, plus c, and we get c equals 2. And so finally, let's put in y equals, well, the gradient is minus 3x, and we've worked out c to be positive 2. This is a trickier example. We're asked to find the point of intersection of the tangents, 2 tangents here, to this curve. And they're tangents at 1, 0 and 3, 2. So you can sort of imagine what's happening here is we have a curve, and we get one tangent here, it goes something like that, and we get one tangent here, and it goes something like that, and we're asked to find where they cross. And so what we're going to have to do, first of all, is find out the equation of let's call this tangent 1 and tangent 2. So we're going to do the equation of a straight line twice. So first of all, we have sets of coordinates. Here we go. We need a gradient though, so let's find dy by dx. So we differentiate 2 to get 0, minus 3x, differentiate to give minus 3, and x squared is 2x. Now, we have 2 points, so when x equals 1, the first point, 1, 0, dy by dx is minus 3 plus 2, which is negative 1. And at x equals 3, the other point, 3, 2, dy by dx is equal to minus 3 plus 6, which is 3. So getting the equations of the lines then, y equals mx plus c, I'm going to use the point at 1, 0. So 0 is equal to minus 1 times 1 plus c, so c is equal to 1. And so the equation of that line is y equals minus x plus 1. The second one, we've got the point 3, 2 and the gradient of 3. So again, if we use y equals mx plus c, we get 2 is equal to 3 times the x coordinate of 3 plus c. And so here we get c is minus 7. So this is the equation y equals 3x minus 7. Now, we have the equation of the 2 tangents, tangent 1 and tangent 2. And what we're going to do is solve those simultaneously to see where they cross. So I'm going to write them just above one another, minus x plus 1, and y equals 3x minus 7. And I'm going to subtract one from the other. So 0 is equal to minus 4x, and 1 subtract minus 7 is actually plus 8. So moving that around, 4x equals 8 and x equals 2. Now going back to one of the equations, I'm going to pick 3x minus 7, so because the x term's positive. And let's substitute x as 2 in that, so y is equal to 6 minus 7, y equals negative 1. And so the coordinates of our intersection then, x is 2 and y is negative 1.